Welcome to Study Loop.
In problem 6, we're going to be using some data on the lifetimes of handheld video games to test the claim that there is no difference in the lifetimes of two brands of these handheld video games. And we're going to be doing so using the Wilcoxon rank sum test at the 0.01 level of significance. So we have to follow 5 steps. The first step is to state the hypothesis, then we give the critical value, we rank the data, work out the value of z, and then compare the critical value of z and the calculated value of z so that we can make the decision to fail, to reject, or to reject the null hypothesis. So let's do the first thing, which is to state the hypothesis, the null hypothesis and the alternative hypothesis. So the null hypothesis is that there is no difference in the distributions of lifetimes for the two brands. There is no difference in the distributions of lifetimes for the two brands. Then the alternative hypothesis is that there is a difference in the distributions of lifetimes for the two brands. Next, we're going to state the critical value, and in our case, the level of significance is 0.01, and therefore the critical value will be plus or minus 2.58. Next, we have the data ranked for the two brands of video games, and we are going to consider N1 and N2, where in this case N1 is a sample size for the smaller sample, and since these samples have the same number of video games, 11, we have to pick any of the two. And in our case, we're going to use brand B as N1. You can also use brand A and still arrive at the same decision at the end. So the sum of ranks for brand B is given by 140 when we add up the values 3, 4, all the way to 22. Then mu r obtained from this formula is 126.5. Sigma r obtained from the substitution is 15.23. And now we can substitute the values into the formula for z, and that will be 140 minus 126.5 divided by 15.23. When you work that out, you obtain a z value of 0.8865. At this point, we can compare the calculated z value, which is 0.8865, to the critical value of z, which is 2.58. And in our case, we see that 0.8865 0.65 is less than 2.58. And for that, we make the decision to fail to reject the null hypothesis. So in our case, we conclude that there is not enough evidence to reject the claim that there is no difference in the distributions of light times for the two brands. So the researcher had a claim that there is a difference in the distribution of light times for the two brands, but there is no evidence to support this claim.